Hi everyone, I could not conduct the tutorial on the weekend, so I'm recording this right now. Um, Hopefully it will help you a little with the quiz tomorrow. So this is the first question, and we are given the CDF in this question. We need to compute the PDF. The CDF gives us the cumulative probability computed by integrating the PDF. So we'll partially differentiate this function by x and then by y to compute the PDF. This is part one. You can email me and ask me any questions if you have. If you don't understand something here, or if there are more questions regarding the quiz syllabus. This is the answer to part one. We have found the joint PDF. In part two of this question, we are supposed to find the marginal PDFs of x and y. So to find the marginal PDF of x, we'll integrate over all the values of y, and we'll integrate the joint PDF over all the values of y. And similarly, to find the marginal PDF of y, will integrate the joint PDF over all the values of x. So we found this PDF. Now we'll use this to find the marginal PDFs. This is the marginal PDF of x. Similarly, you integrate the joint PDF over all the values of x to find the marginal PDF of y. You can compute this on your own similarly. And move on to the next question. Okay, again, in this question as well, we are supposed to find the marginal PDFs of x and y. I'm going to write the expression for these two, but I won't compute it entirely. I'll move on to the second part after that. For the second question, we are supposed to find the probability where the random variable x is always greater than y. For this, we will again integrate the PDF, but there are some restrictions here. So we know that both x and y can lie between 1 and 0. But for this particular part, our x has to be greater than y. So if we choose y to be anywhere here, for instance, here I choose this point arbitrarily, then my x cannot lie in this region. It has to lie somewhere here. Visualizing this can help us choose our limits. So I write the integral. Basically, while putting the point y anywhere on this line, we could place it anywhere, like from 0 to 1, we could place it anywhere. So this is why I chose limits for y. And then for x, we have to choose a point between y and 1. So we go from y to 1, since x has to be greater than y. And I write my function as it is. These are the limits for x. So you have to be careful about the order. And these are the limits for y. You could have also switched the limits and taken the integral by switching the order. And you can make sense of it on the number line yourself. I'll just complete this integral. 9 by 14 is what I get. Let me confirm the answer though. So some but it. What is next question? Oops, what is it? In this question, we have three random variables x, y, and z, and we are told that they are independent and uniformly distributed. We have to compute this probability where x is always greater than or equal to the product of y and z. Now, this looks scary at the first sight, but let's start from what we know about this question. We know that three variables are independent and uniformly distributed. So, wait, sorry. Each of x, y, and z can range from 0 to 1. And their value, the value of their PDF would be constant somewhere here, which would clearly be 1. Because for instance, we have the PDF of x as, we can directly write this down like without finding the joint PDF because we have been told that the three random variables are independent. So 1 over b minus a, which is 1 minus 0, which is 1. And that would be the case for y and z as well. Because the range is the same. Not the range, but the interval, the domain. All of these are equal to 1. Now we know that the joint PDF of x, y, z would be equal to the product of the three marginal PDFs. Why do we know this? Because again, the three random variables are independent. So we can write this down. Now we can use this joint PDF to find the probability where x is always greater than or equal to the product of y and z. So the limits of, write this down. Find the probability we integrate, and the limits of x will be always the product of x, y. Sorry, this should be y. Oops. And then we can choose y from anywhere between 0 and 1. Similarly for x, the limits are 0 and 1. So for questions like these, make sure you compute the Martian PDFs first and then use them to find the joint PDF. And then everything will flow. You'll be able to solve the question. This is exponential distribution. Since the time elapsed between consecutive successes is the random variable and not the number of successes between the time interval. What I'm saying is कि अगर हमारा random variable is the time between two successes and not the number of successes between a given time unit, then it is exponential distribution. But if it was the number of successes between a time interval, that would have been Poisson distribution, which is discrete, and exponential distribution is continuous since it's time. So in part 1, we are supposed to compute the expectation of the time between two intervals. And we know that the expectation of exponential distribution is given by 1 over lambda. And our lambda here is 1.8. So it would be 1 over lambda. 1.8 plus. Moving on to part 2. Again, keep in mind our random variable is time between two successive successes. So we are using exponential distribution. You should have a very strong grasp over where we use exponential distribution and where we use Poisson distribution to compute this. this is the CDF. And we know that the CDF of exponential distribution is given by 1 minus e power minus lambda. On CSF. Now we move on to the next part. What is the distribution of the number of workers visiting the first aid room during a 4-hour period? Now, in this question, you can clearly see that the random variables is the number of workers arriving in a given time period. So that would be Poisson distribution. And our parameters for the Poisson distribution would be greater. Lambda into t, where lambda is 1.8, workers arriving in an hour, and we'll adjust it according to the time interval we are given for the distribution, and that would be 4 hours. 7.2. In the next part, we are supposed to use Poisson distribution. What is the probability that at least 4 workers visit the first aid room during a 4-hour period? The number of workers by W. At least for the other, the value is greater than or equal to 4. And again, since I cannot possibly compute the probabilities at all integers greater than 4, so I'll just complementary rule. We know the formula for Poisson distribution, which is sorry. input a final answer now. I'm going to end this recording, but before I end the tutorial, I want you to know that I have not covered everything in this tutorial, but I can tell you what things you should focus on. You should know how to compute conditional PDFs. You should know how to compute conditional expectations. I have not covered that in this tutorial, but एक दफा देख लो सब कुछ. It's really easy, but तभी होगा अगर पहले से पता हो कि कैसे करना है. And make sure your concepts are very clear on independence, on dependence, and joint PDFs. Baki, if you know exponential distributions and Poisson distributions, you'll be good to go in tomorrow's quiz. Otherwise, बुरे हालात होंगे. Best of luck for the quiz. I hope it goes well for all of you.